stone.
We should show up the first period in Spanish.
We show up for first period. Right away.
Okay, what we're going to take a look at today is areas and perimeters. The shapes that you did for today were the like square, rectangle, triangle, and those are on your notes, but we're gonna add to that like a parallelogram, rhombus, kite, trapezoid, so a few more formulas. The screen is pulled in, so some of my pictures are a little distorted, so it's not quite exactly what I want it to look like, but that's what it's looking like today anyway. So first of all, what is perimeter? We've talked about perimeter before. What is that?
The distance around.
Distance around a figure, correct. Total distance around a figure, we measure it in linear units like just inches or just centimeters or just feet, or miles, whatever we're in. When we deal with a circle, we don't actually call it perimeter because one definition of perimeter is add up all the sides, and a circle doesn't have sides. When we mention total distance around a polygon, a circle's not a polygon, so it doesn't fit this definition either. But same idea, circumference will be perimeter of a circle. What is area? When we found the area of a triangle or a rectangle, what are you finding? What kind of units? Okay, it's square units, because you're trying to like fill it or cover it, aren't you? You can't fill or cover with something that doesn't have any space to it, basically. So region covered by a shape, measured in square units. It might be square millimeters. Those are really, really tiny. It might be square feet. It might be square yards. You know what a section is? Living in Nebraska, you know what the terminology is?
Square mile.
A square mile is a section.
What size?
What's the surface area again?
Surface area will be when we have a three-dimensional shape, and then we're trying to find the area of every face total, and that's what our next chapter will involve, surface area. So yes, when we're doing area, we're on just 2 dimensions, we're flat shapes. Then when we go to 3-dimensional, we call it surface area. All right, so how do we do area of some weird shapes? Like you had those tangrams. We could find the area of each piece of that tangram and figure out, like if you put it together and made a square, what the area of that square would be. Then if you move the pieces around but still used all 7, the area of your parallelogram would still be the same as the area of the square that you just had. As long as you're using those same pieces, not throwing anything away, and not worrying about the blank spaces, just what the shape covers, it'll have the same area all the time. That is one way to think about the area addition postulate that you'll find on your notes. Area addition postulate is just saying that the area of a region is equal to the sum of the areas of its non-overlapping parts. So if you think of the tangram, there's a lot of pieces there, they're not overlapping. If you know the area of each of them separately, you can add it up and get the area of the whole thing. So that idea is how you would do this type of problem. How would you find the area of this as an example for your area addition postulate? How would you find the area? Chase.
You would find the perimeter, or the area of the little square.
Okay.
And find the area of the larger rectangle.
Okay, so he's kind of saying divide it into pieces. And how he divides it and how someone else divides it might be different. So draw this shape for you. Fairly close to scale. Mine's kind of distorted because it's not letting it go as wide as it should. So my 15 and my 7 look about the same length. But draw yourself a similar type of figure. Label those same units. Then you decide how would you divide it into non-overlapping parts so that you can find the area of each of those pieces. I'd say you're probably going to divide it into like 2 rectangles or maybe 3 rectangles. Find the area of each of those rectangles. Careful what measurements you're using. when you do that. If you wanted to make it really complicated and make a whole bunch of triangles, you sure could. As long as it covers the whole thing and it doesn't, they don't overlap.
Yeah.
Okay, how did you divide this? Did you go vertical? Yeah? Anyone go horizontal? Yeah? Can you do both? Make it into 3 rectangles? Why would you do that? Well, depends upon what measurements are there. And perhaps the measurements would be there for the little ones. This one, I would say vertical probably is the best one to go here, as far as what measurements I gave you. So if you went vertically from this corner down, you had a 15 by 7. Doesn't look like a 15 by 7, but that's the measurements. And then you had a 20 by 18. And then you're adding those together. Area was 465 square inches. Now you read it square inches, but the exponent goes on the label. It doesn't go on the number. Because if you put it on the number, that means I have to take 465 times 465 to get the answer that you want. So it's not the number that needs to be squared, it's the square units. All right, so rectangles, we did base times height. I think the second one down is rectangles in your notes. First one is parallelogram, and I don't know why that pixelated so bad on there. But I'll show you what that's talking about. What that's doing is trying to show you how we can get the area of a parallelogram from the area of a rectangle. Okay? And parallelogram looks like this type of shape. If we would go from like a corner or really any place perpendicular, I can cut that triangle off on the left here and just reposition it. If I move it over, because of the angles being the same, wouldn't that create a rectangle? The area of a rectangle is base times height. So base times height. Now if I move the triangle back, does the base change length when I take it off of here and move it to the left again? No, that's still the base. Still the very same measurement, times height. So to get the area of the parallelogram, base times height, just like a rectangle, base times height. What you use for the base is a total side of the parallelogram. The height has to be perpendicular to that and get you to the other side. Sometimes they picture it out to the right here. Maybe they'll put it kind of in between, clarifying that it's perpendicular. Maybe where I had here, a lot of different places they can picture that height. But the height of the parallelogram is how far between the parallels. So area of a parallelogram, if the base is B and the height is H, it's A equals BH. We've got the rectangle, and I think below it in your notes I put square. So we'll do some with measurements here in just a second if you want an example. So base times height can apply to more than one shape. All right, ready for an example? For the most part, any of these formulas, when we say base, is a side of the shape. Sometimes it's a specific side, but many times it could be any side. Height is perpendicular, an altitude idea. It has to get you to like the far corner or the far parallel side. So knowing where the base and height are in the figures is important for you. All right, and I just mentioned that. When you do perimeter, I guess I didn't mention this class period, there are formulas for perimeter. I really don't focus on those at all. You'll find some in your book. I didn't put any of them on the wall, because if you just know perimeter is the total of all the sides, no matter what shape you're working with, you can find the perimeter. There might be some sides that have the same measurements, like in a rhombus or in a rectangle, making it easier to know what to add up. But just keep in mind, for perimeter, add up all the sides, instead of trying to memorize a whole bunch of formulas. Here's a parallelogram for you. So I've given you some numbers, and I've given you more than you need. So which ones would you use to find the area? So calculate the area, and why don't I have you put some of your final answers then on your marker board, but you can sure do the examples in your notes. Just give you the final answer to look at. Find the area. All look good. We'll talk about that later. Okay, I'm looking at how you're labeling. What does the 2 tick marks mean?
Inches.
Inches. Okay, 450 looks like the right answer. Now, don't put the 2 tick marks and then a 2, because that could look like it's the 112th power.
Oh.
Right? Okay, so when you're doing
What is that?
in areas, you do have to write out the IN for inches instead of the tick marks when you're
That's a
doing the
math there.
square. Okay, so square inches, don't use the tick marks. You can use the tick marks for inches. If there's 1 tick mark, it means feet. And again, don't do feet squared with the tick marks. It looks like the 12th power sometimes. Okay, question on this one? What would be the perimeter of this parallelogram?
30, 60, 50, 90. Did I do that right?
I don't think you did that right. I was with you on the 30 and the 60. Okay, because you're gonna add
Oh, the
17 and 17, you're not really gonna use the 15 when you do the perimeter. So you need to, I guess, pay attention or know that the height is the perpendicular, but the perimeter would involve the slanted measurements. Okay, here's another parallelogram. 11 millimeters and 34 millimeters. One of those is the base. And you have to have the perpendicular height that goes from whichever base you're using to its parallel side. You have to find a measurement. And the way they've got it pictured, your 11's going to be the base. But then to figure out the height, you have to get this vertical height figured out. How can you do that? See this right triangle? Yeah, Pythagorean theorem. 30, don't know this one. Do you know the hypotenuse?
Yes.
Yes, it is
34.
34 because the opposite sides of a parallelogram are congruent. Okay, so first step, Pythagorean theorem to find the height. Once you find the height, what's the base? Millimeters. Do you have inches squared? I didn't notice it. far as finding the dimensions.
Is it 30?
I don't know what I'm doing here.
I think I did 30 plus 11.
I did something wrong.
Right, when you're doing Pythagorean theorem, 30 and 34, when you do the base of the or the parallelogram, you do not add the 30 on. But the base is always a side of the shape. So 11 is the base, and then your 16 you found was the height, so 11 times 16, 176 square millimeters. All right, now find a missing base. Okay, I'm telling you the height is 56 yards. The area is 28 square yards. What is the base? And I know this one's probably easy somewhat, but always, what I'm gonna say is always start with the formula. So write down the area formula for the parallelogram. A equals B times H. Fill in A is 28. H is 56, so you're doing substitution. You just have to solve using algebra to find B. What are you going to divide by? Units, I'm not seeing the right thing on everybody's. Daniel, did you change your units? Yeah, do you have squares on it?
Yeah.
It shouldn't have square. What's widening? It's not a usual abbreviation. So we're
Would that be squared?
how about 28 instead
Oh.
of 27? The number is not squared. It's square units.
Yeah.
So how would you solve for B?
Divide by 56.
All right, that one you're dividing by 56, and so you're getting 1/2 of a yard for the missing base. Yeah. Okay, triangles and trapezoids would be next. My notes are a little bit pixelated. You can probably read it better on your note sheet. So I didn't do a square example. I didn't think you needed one. I think you girls have what you need. I didn't make one. I thought you could make one if you want to, or draw. You know how to draw a picture if you need it. So. Did you get the worksheet taken? Okay, triangle is 1/2 base times height. Trapezoid is 1/2 base 1 plus base 2 times height. Trapezoid has two different bases. Do you remember which sides are the bases? The parallels. Okay. So you would add the parallels and take half of it. So it's like you're averaging the base lengths and then multiplying by the height to get the trapezoid. I want to show you where those formulas come from, at least to some extent. A triangle, how did they get 1/2 base times height? Well, if we take a second copy of that same triangle, we can flip it over and it would fit directly on that first one to make what kind of overall shape? Parallelogram. We've already talked about a parallelogram. Parallelogram would be base times height, perpendicular height. So base times height would be this whole parallelogram, but if I want just a triangle, it's only half of the parallelogram. So 1/2 of base times height for a triangle. Trapezoid would be the same kind of idea. You have a trapezoid, make a second copy, you flip it over, it would make a great big parallelogram. What's the base of the parallelogram in trapezoid terms? Let's see, let's say I call that base 1 and this base 2. And here would be base 1 and base 2 when I flipped it over. So isn't this total base 1 plus base 2? Okay, so the the parallelogram would be base 1 plus base 2 times height. We'll kind of dash that in here. Trapezoid would only be half of that whole region. So using a second copy, we can reason through or maybe see why the formula is what it is. It's half of the great big parallelogram that would have been formed. All right, so how do you figure with those? Let's find the area of the triangle. You've done some triangles on your worksheet, so I mean a little harder one. You have to figure out the missing measurement. Find the area of the triangle. First find your missing, find your missing side.
Change. Reed's good. Are you going on a trip over there? Yeah. Where you guys going?
Okay, what was the missing base? 16? And again, if you recognize Pythagorean triples, use that. Maybe you recognize that 12, 16, 20 would be a multiple of 3, 4, 5. Okay, then your triangle area was 1/2 16 times 12, 96.
Yay. I still wrote inches.
Okay, here's another triangle. Find the area of the triangle. You're gonna have to learn your 30, 60, 90s because I'm gonna take that down off the wall pretty soon.
No. I'm taking a picture of you.
Well, because Mrs. Hinkle said when they come to trig, they need to have that in mind. They need to know their 30, 60, 90s.
I'll memorize them.
So what's something you can make sure you would remember? The hypotenuse is always twice as long as the short leg. So if you at least get that, you can do most of the problems.
Oh.
What's another thing you could do if you forget the 30, 60, 90 pattern?
And then both sides.
Yeah, SOHCAHTOA you could use, right?
I was about ready to use that.
This one you cannot do the Pythagorean theorem on very easily because you only have one side. But we will be getting to problems where you could solve it multiple ways. So let me check for this one. Those both are the same. Yeah, those are right. Are you getting the sides?
1.
What was the short leg? 14, and the base was 14 times the square root of 3. Okay, so now if you're doing area and you just want to keep it exact, don't go to decimal. 1/2 times 14 times 14 square root of 3. You can multiply the 1/2 times 14 times 14. You just can't easily multiply by the square root of 3. So you could come up with 98 times the square root of 3
What?
as the exact answer. if you actually multiply by a calculator square root of 3, you're gonna have to round it, and that's not exactly the area. So I would be looking on these kinds of triangles for the exact with the square root of 3 part of it. But questions related to that one, some of you indicated you really weren't getting that answer. Need any help? No? Okay, let's try another. Find the area of a trapezoid. First base is 8 inches. Second base is 5 inches. The height is 6.2 inches. Use your correct order of operations. All right, this one ends up 40.3 square inches. Okay, looks like we got that. All right, find the second base of this trapezoid. So work backwards type of problem where I'm giving you the area and you find one of the bases. What do you need to start with? The formula. Write down the formula for the area of a trapezoid. Two different versions you could do, either with the 1/2 fraction or the divided by 2. There are multiple ways you can go about solving it.
God doesn't do that.
That's so
How would you, how would
I
you
can do
solve
this
that?
stuff, this stuff. Like 4 seconds.
fast. 231 times 2 divided by 11 minus 2.
Did you type the whole? Yeah. If I type it in, I usually get like the whole thing. Doesn't follow the whole operation. It messes up. I don't know why I do. I have to. The actual answer is 21.
It's out of batteries.
But you're gonna say it's charging.
I forgot to charge it. It was like, I was concerned it was gonna like blow up yesterday when we were making a test. That would have been really bad because this doesn't have no side or back.
Seriously?
Well, it probably does, I just don't know how to work it.
Can't figure out a simple calculator, but you have like a supercomputer. that
It's
does it.
actually easily simple.
Okay, answer on this one, 19. I don't know if you did the steps that I did, but we can solve it another way.
Yeah.
The things you can do, what I did was I simplified the 11 times 1/2 instead of doing those separately. 11 times 1/2 was 5.5. Then instead of distributing, I divided by it. and subtracted the 23, but I think a lot of you went in different order. You need me to go through a different type of solving it to get the 19? Caleb? You got 20, 20. You had 2, 30. What is, I think it's 10 times 11. I don't think that's the right number. Okay, anything else? Okay, there was a trapezoid. Let's look at a rhombus and a kite for the last two. Now reminders, diagonals on a rhombus are perpendicular, diagonals on a kite are perpendicular. Actually on a square they're perpendicular also. You could use this formula for a square also if you wanted to. They also bisect each other on a rhombus but not completely on a kite. Again, it's a little pixelated today, but the area of a rhombus or kite is 1/2 D1 times D2. What do the D's mean? Diagonals. So you multiply the length of both diagonals and take half of it. Why the heck would you do that? Oh, let's take a look at a kite. I could do a kite or a rhombus, but I'm going to draw a kite up here. Okay, a kite. To find or where this formula comes from, I'm going to say, let's enclose this kite by a rectangle. Because we can find the area of a rectangle easily. So how long is this rectangle related to the kite? Isn't that the length of this diagonal?
Yeah.
And how tall is my rectangle?
What? Oh my goodness gracious.
Okay, the height of my rectangle is the diameter, or the second diagonal. So if I did the whole rectangle, it'd be diagonal 1 times diagonal 2 for the base and the height. Now the kite, if I divide it along those diagonals and look piece by piece, isn't the kite covering half of this rectangle? And it's covering half of that rectangle, and half of that, and half of that? So it's half of that total, so that's where they got the formula from. Kind of neat to see, rather than just what is the formula. So the same kind of thing could work if it were a rhombus. All right, here's your kite. Define the area. Now my pictures are stretched a little bit one way than the other, so you might want to redraw it more accurately. The 29 and the 35, think about a kite. Would that top edge have to be 29 and the right hand edge 35? You might draw it so that they match up better. But we need the length of both diagonals. The 28,
Is that the entire one?
no, that's just from the intersection at the center to the corner. But yeah, if it were the whole thing, sometimes they write like D1 equals, meaning it's the whole diagonal. But since they didn't put that in, it's just that little piece. So is X 28? Yes or no?
No.
Which way would you fold this?
How long?
Okay, it would be folded along this X 28 line, right? Not folded this way. Notice the 35 and the 29 would not match. So that might visually help you know that X is not 28. If it were a rhombus, they would be the same. So how can we find anything? Are there right triangles?
Yes, yes.
Where?
Like the thingy made out of where the dotted lines intersect.
The diagonals intersect to make perpendiculars. So I know this isn't the very same one that's up there, but you have a 28 and you're trying to find X. What other measurements. So I've got a 35, 35, 29, 29. Okay, so how can I find X? I think I have to find Y first.
Why do you have to find that?
Why do I have to find Y?
No.
I don't have enough measurements the other way. Okay, so Y is a side of a right triangle that has 35 and 28. 35 is the hypotenuse, 28 is one leg. Find the other leg.
Let's see.
What final answer? Okay, I don't know the final answer yet, so hang on to that. So what is Y? 21?
21.
Okay, 21. And we said you would fold it so that the Y was the same on each side. This is 21, so one of our diagonals is 42.
That ruins that.
Okay, can we find X now?
21.
Pythagorean theorem again.
20.
21 and X as the legs.
20.
29 is the hypotenuse.
I'm a little stupid to see if I'm right. Which I know I'm right. But no, I'm
What is X? 21 squared plus X squared equals 29 squared. X is
20.
20. Okay, so if that's 20 and 28, this other diagonal is 48. Okay, so finish finding the area. 48 times 42, half of that.
Is that like a mean eliminate?
Final area was
Did I do it? I did it.
1,008
Yay.
square inches. Okay, thumbs up or down? All right. How about find one of the diagonals? So I'll go backwards problem on kites.
There we go.
Start with the formula. Okay, so write down the formula for the area of a kite.
I need to write that down. Wait, what was 1/2 times d times d2? G1 is loss 14. Use that.
Okay.
238 times 2.
And you don't really have to do a distributive property because it's just everything multiplied together. There's no add or subtract. Just 1/2 times 14.
Is that divided by 14? Is that the answer?
Label the units. You're finding the length of a diagonal, so you should not have square units on this answer.
Did I
Ready
do
to
it
see
right?
it?
I have that. Yay.
Okay. So the formula filled in, I took 1/2 times 14 and got 7, and then divided by the 7. So 34 inches. Oh, I got that labeled wrong. Square inches. I'm going to change that. 34 square inches. Yep. He was thinking like I was thinking. Wrong.
What's wrong?
Ouch.
Can we trust you with anything now?
Ouch for me or ouch for him? Huh? Okay, here's a rhombus. Somebody said you were putting the notes in the wrong spot. Here's a rhombus. Find the area of the rhombus. The side lengths are 15 meters. One diagonal is 24 meters. Are the diagonals the same length in a rhombus?
I'm gonna go with yes.
No.
No. Answer's no.
Answer's no. Not, there's probably a certain point, if that rectangle and rhombus combine to make a square, that they would be
Still a
congruent. But,
rectangle.
yeah, for the most part, they're not. Which one is the 24, the long or the short one? I don't know. So just put it on one of them. So draw yourself that rhombus. One diagonal is 24.
Boop, boop, boop. That's a triangle too.
When you put the other diagonal in, what happens to the shape or the other diagonal? Becomes 4 triangles.
What's the date?
The triangles are right triangles because the diagonals are perpendicular. The diagonals also bisected. So the 24 becomes 12 and 12.
Okay.
You've got a 15 for every side. You probably need to find part of that other diagonal.
80. I feel like that's not right.
Recognize Pythagorean triple? No? Okay.
Stop.
Pythagorean theorem then.
I don't like this answer. I got 81 for them. You did not get 81. No.
Not 81, no.
Oh, it's 9.
9. So this little piece is 9, and that one's 9.
So 18
So one diagonal's 18, the other diagonal is 24.
times 25.
Okay, so should be taking 1/2 times 18 times 24, which is 216 square meters. I labeled that one right. Question on that one? No? Okay. One more rhombus, I think. Find a second diagonal of this rhombus.
So
First diagonal is 3 meters. The area is 12 square meters. What's the other diagonal? It's like some of your bags need a new eraser.
Yeah. I did.
whatever I got here wrong. So that's 12 squared.
Okay, answer?
I
think it's 8. 8 meters. Alright, question on that one? Okay, let's just take a look, see if I forgot anything. Oh, converting. What would 1 square yard be in square inches?
36.
Okay, before you get on those wrong answers, draw yourself a square. Draw yourself a square, label 1 yard, 1 yard, base and height,
Oh,
but 1 yard, but the units there, so you know what you're doing.
yard.
Okay, now we want to think of that as in inches. So replace 1 yard with how many inches that's equal?
36 times 36.
36 by 36.
That's a big number.
So,
Well, I didn't hear this number come out of it.
1,296.
So it's 36 times 36, or 1,296 square.
I just saw that.
36 times 36.
Yeah, but like, it was like 2, then it'd be like.
If there were 2 square yards, something, then that number times 2. Is that true?
Wouldn't it be that number times 4?
Or if you're going to,
All
right. Okay, how about a square mile in square feet? Okay, so your square,
5,000.
1 mile by 1 mile, 5,280, probably should write that number down. 5,280 feet in a mile. So that means our square is 5,280 feet by 5,280 feet. And that would be, when you multiply, how many square feet?
Oh my goodness.
27,888,961.
So when you are converting in the square units, it gets a lot bigger than you would expect because you are working with square units instead of just linear units. So it might be safer when we do some problems to convert when it's not square units. And convert before you calculate rather than after. So watch out for those. Right, and I think I just had some like samples. I think a few problems might have variables thrown into them when you're doing some calculations. The homework is a worksheet. Yeah, so like the area answer there, you have 11.5x and 20x.
Whoa,
With that area. Okay, worksheets were handed out to a few people who are going to be taking. Okay, anybody have one in this row?
How much?
Okay, this row have one yet? I think Gracie has one, okay?
I have one now.
Okay, and Chris, do you have one? Okay, the worksheet is your assignment for tomorrow.